There are some really cool techniques I want to show you that are really useful for creating functions and working within the function editor. So I think one of the best ways to show these techniques is by creating a wood surface. So I'm just going to add in a cube into the scene. And I do want to note that if you go to File and Options, under Units and Coordinates, I'm using 0.1 meters as my conversion of view units. If you're working with 1 meter instead of 0.1 or a different unit, you probably won't have to change the actual number on your side to follow along, but just increase the material scale. Either increase it or decrease it, 0.1 or using 10. And that's just for the overall material scale. So I'm going to double-click on the material for the cube. We're going to go ahead and give it a name and call it wood. I'm going to change the mapping mode over to World Standard. And we're going to start by creating a color map. So right-click and go to Edit, Edit Color Map. If you double-click, it will ask to load one in. And when working with color maps, and also working with filters, we have clamping mode options. There are some cool things you can do by using the clamping modes, and also save yourself a lot of time in creating certain functions. So I'm going to edit the color. Go ahead and modify just this first color on the right. And then double-click over on the left side to add a darker, more brown color. And another one right next to it. And then starting about midway through, add another material or another color that's going to be closer to the starting material. So the colors I'm using for the higher, you can just copy over the RGB values if you're not using View version 8.4 or higher and you can't load in the included color maps. And I am going to be adding some additional colors to this. But first I want to show you just kind of how the color map works and how we can manipulate it. The color map uses numeric input up at the top to control the color. If we take a look at the map itself, basically if we were to look at this numerically, we would have -1 over on the left side and +1 on the right, with 0 being the center. And then when we go back to the color map and we take a look at the upper and lower clamping modes, right now by default it is set to clamp. So in other words, anytime you're outside of the range of -1 or 1, it's going to continue the color on each of the ends. So we're going to replace the constant node that is a placeholder up on top, just selecting it and going over to the left and adding in a fractal node. We're going to use Purlin Noise Gradient, which is the default. This will actually work quite well for a wood surface. And I just need to decrease the roughness a little. So if we look at the output of this, the numeric range isn't very high. And we are going to want a smaller, largest feature option or output. And then I am going to increase the Z scale by 5. So from 1 over to 5, and in order to get a better output to control the color, we would need to increase the gain. And then we'll start to see the color map showing. And I'll go ahead and just render this out, just using the final mode. Once the wood surface is complete, a broadcast mode or higher is really going to be needed. So we don't really see much variation overall in the material. Even if I decrease the scale, there's not much there. And you can definitely see where it's getting clamped out because we start to go beyond the range. So if you were working with a clamped mode, the way to get the rings into the surface would involve going into the material and creating a ton of different color points. That would be dark and then light and then dark and then light, and that's just going to take a lot of unnecessary time. So instead, what we want to do is manipulate the input, and we can change the clamping modes to repeat. Now, once we're repeating above 1 and -1, it's going to take the color from the right, and then there's going to be a very sharp cutoff to the color on the left. And if I go ahead and just increase the gain a bit more, that might be enough to show the repeated value. What we're going to notice is that very sharp line. Now, in a lot of situations, that might be okay. You might want to have something that's going to cut off very sharply like that. But I'm going to go ahead and set my scale back to 1. I would like it to transition a little bit better. So what I'm going to do is edit the color map and go to the first key point color, right-click and copy this color, and then double-click to create a point all the way on the left. It doesn't matter the color right now, because we're just going to right-click and paste the identical color over on the other side. This way we have a transition between these two colors rather than a very, very sharp cutoff. We can also see this showing up in the node preview. Now, another way we could sort of achieve the same effect is to mirror the value. The only problem is, if we're mirroring it, then it's going to dip in and out, and it may not look the way we would want the wood surface to look. So if I render this out now, we're going to see a much better transition. And if you want to compare to the scale we had before, I'll bring it down to 0.1. So instead of being extremely sharp cutoff, we have a little bit of a better transition. If we want to extend the transition, we would need to modify the color map and move the point over. So the more we move that in, the more we can increase the transition. You could also set different colors, but I don't want to be using too many colors in this. Because the whole point is to have something that's simplistic to be able to create a pretty nice output. So we're going to go back and edit the function. And now that we have that repeat, we can basically just increase the output. So basically like increasing the gain of the fractal in order to get it to continue to repeat, to get rings out of it. Now, we don't want to just continue to use the fractal and use very, very high gain amounts, because the fractal itself in its current state, if we were to use it to control a bump, it would be very difficult and very extreme because these values are becoming so high. The extension showing in the function node preview is just under 10, so 10 for a bump is going to be very, very high. So I'm going to take the gain and bring it down to 10. So our extension's 1.8, so maybe I'll bring it down so that our extension does not go beyond 1. I'll go ahead and set it to 5. And we're not going to see a lot of repeating. Still just kind of that one repeat. So what we need to do is modify this link in the numeric value before it reaches the color map. So what I want to do is take the filter that's already added in by default, or you can add a new filter by selecting the little F over here after the link is selected, and change that over to a multiply. Now we may need to use very high values, but we want to get a very extreme value in numeric input to start to see rings showing up. So let's go ahead and start with 50. And now I am going to need to bring my scale back up. So we'll go click OK, OK again. I'm just going to close everything out for right now, set it to 1, and we can take a look and start to see the surface coming together. Because there's no MIP mapping involved with the procedurals, anytime we're going to see this very sharp decline, as we do on the side, there's going to be some rougher areas that will need to get anti-aliased, which is why we need to use broadcast or higher in order to remove those. So some complex wood surfaces are going to require slightly higher render time, but they do look much better, and it is probably one of the best ways to create the wood. So now we want to add more variation to the color, because right now it's going to be basically the same throughout as the rings continue. So what I'm going to do is blend together a couple of different color maps. So what we can do is select the color map, and just click off of it and add another color map, which should duplicate our current color map, where we still have the repeat mode set for the clamping, and also the same color values. I'm going to connect this to our simple fractal, and now we have something that is closer to just the original output. So a lot more variation. And I'm going to select the color link to the color output and add in a combiner node. And we're going to use the blender, connect these two colors, and we could very easily just blend them together. And just take a look at that. So that gives a nice overall transition between the colors just by blending. We could also add these colors together. That gives us more of a natural wood look. And then we can also multiply them, which is going to be a lot darker. So let's go ahead and set it to blend for the moment. And just bring it down a little. What we can also do is connect and add another multiplier in order to modify the blending material. So select the multiply, create a new filter on the other link, just so that we get the same filter and we don't have to change it. But we do want to modify the multiplied output. So we can go ahead and change that to, let's say, 5. And now we're going to have more variation matching that multiplied value. If we don't want them to be exactly the same and follow the exact same contours, we can use a similar fractal to control the secondary color and just modify a few values. So I'm going to select the fractal, just click off of it, add a new fractal node, which is going to be identical, replace the link connecting to the altitude on the other side, and what I want to do for this larger one is just increase the roughness value. So that way we can have a little more variation within it, since it's larger and it's not going to be so smooth, but not modify the original rings that we're showing on the other color production. We can also modify the roughness value of the original fractal, but the only problem is with the rings getting so small, if the roughness is too high, well, you can see what happens. The main problem is once we hit the repeating areas where we have very, very thin rings, even with only a slight increase, it's going to cause some anti-alias problems, and that's not something we really want to do. So we can use the larger variation to increase roughness. So it really kind of depends on the look you're going for. I'm going to decrease that roughness a little. Another thing we could do is there is a really cool option for the Purlin noises. We can go to Edit and select a ridged noise, and normally that's going to create some higher peaks if we were to use it, say, for a bump output or using it to control a terrain. For materials, it can work pretty well. I am going to do it on the lower range, the thinner rings. And once I do that, you'll be able to see much tighter grouping of the rings. So if you were looking for something like that, you could turn on that ridged mode. But sometimes it does create some weird sort of square shapes within the fractal. Another thing we could do is just kind of shift the color slightly to expand the variation and the overlay. And overall, that ends up looking pretty good. So let's stick with this as our color. And what we want to take a look at now is creating the bump. Now, if I was to directly connect the bump output to what is creating the color, it's not going to work and create rings, because the rings are being generated by the color. The output that is created from the color map itself, there is a numeric output, that is tied into the alpha, or the opacity layer. So if we open up the color map editor and we can see the opacity filter, this filter right now is currently filtering everything out. We can modify this filter, but really it's just passing through that numeric value, and it's not going to give us the same look. So what we can do is, instead of using these values, which are going to end up being way too high for a bump anyway, we can use the color to generate a perfect output of -1 to 1 by adding a conversion. So what I'm going to do is add in a math node, and just right-clicking to pull up the menu. Add a math node, vector operation, or sorry, go to conversions, and we're going to select the color to brightness. We can then connect this to the color map and get our output, and that's going to be within the range and automatically generate our rings. Now, at the moment, this is going to be a really too high for a bump because of the settings that are in the material editor. So that's a bit intense. I'm going to go ahead and click OK and go over to the bump tab and set the depth to 0.05, which should limit it quite a bit. So it's just something very subtle. It will cause a lot more anti-aliasing being needed along the sides, but no more than the color would. So maybe we can bring that up to 0.1, see how that's going to look. And we get some nice grooves in there. So basically, anytime you're working with a function where you have a fractal that is generating a very high output and you want to reduce it, but not have to use the map filter to really clip it in and out, one thing you can do is to add a color map, set the lowest value on the left to an RGB value of 0, which is going to be black, and on the right we want to set that to 255, which is going to be white, and leave the upper and lower clamping modes on clamp. So then we can connect this to any fractal and then add in that color brightness math node, and end up with the output, a really good output that can be used. And that way we can control a color map and use it as a filter. So we could also filter this out and not have to worry about changing the map or the numeric output and getting too high values. So that's pretty cool. I also want to mix this together with the original fractal. So I'm going to add a blender between the numeric output, the bump between the color and brightness, and the output. If we can connect this to either the little rings or to the larger variation, but they're both basically the same size, just different roughnesses. So really just picking kind of the roughness you want to use. We can add them together, or we can multiply them. You can use any of the different settings to really get a nice variation. So that changes kind of the overall bump shape. Now if we want to lighten the entire surface but keep the current color distribution, one thing we can do is add in a color correction node. So I'm going to right click, add color node, color correction, and use the HLS shift. And go ahead and connect this to our chain and extract the luminosity shift. We can use the fractals up on top for this, or the converted version if you really want to intensify it. But I'm going to use the rougher large-scale variation. Go ahead and delete that constant. Because we have values going below in the negatives, it's going to darken. And then overall, the luminosity shift is a very intense change for its output. So we will need to limit the way it's going to affect this. Basically what we're going to do is add in another filter, and first we want to raise it up higher than 0 because it's down in the negatives at the moment. So we're going to add in an offset filter, so we can just raise that up higher. Raising it up 1 should be more than enough, but it is going to over-lighten the surface at the moment. So we also need to cut out the higher range value and basically pick what's going to be the maximum. I am going to reduce this just a little to 0.6, which should be okay. And then go up to that chain, add another filter. And because we don't need to worry about that lower value, all we need to use is the ceiling, which is going to cut out anything higher than whatever setting we enter in. And this does need to actually be added after the offset. So we can add that filter, delete the upper ceiling, and I'm going to go ahead and move a bump over just because everything's getting a little cluttered here. So now we can set the ceiling, and right now it's at 0, so hardly anything should be showing. There are some values going under, so I will set this to 0.7. And then we're going to set the ceiling to be the highest point of brightness. So if I set it to 0.2, it's not going to get any brighter than a 0.2 shift in the loom. It is going a little bit under, so it is darkening. So if I need to, I can still raise that up a bit higher. I think I will just go ahead and raise it up to 1, and then we can set the ceiling. It's really going to depend on the gain output from the fractal. So we could even use another fractal for this if needed. I still think that's a little bright, so we can do 0.2 for the ceiling. And if you were having problems with the lower value, you can also add a floor filter and set the floor to, let's say, negative 0.05. So that way it will shift slightly below 0, but hardly at all. So with that being set up, we can also change the offset. And if we need to, we can just show the output so that we can see what is going to be changed and modified down to the color. But looking at the color also works pretty well. That shift is really a drastic change. So the ceiling I am going to set to 0.05. And it's just kind of a matter of tweaking and adjusting it to get the look you're going for. So if we want to also add a highlight to the surface, you can make it a little more dull, add a highlight. But for the most part, it's going to be very much equal throughout the surface. So we can also set up a variable highlight and connect it to what is generating the color or the bump to limit what's going to be showing up. And it does look like my bump is going possibly in the wrong direction. So if you want to, you can set up a negative bump. And that way you can make it reverse into the opposite direction. So it really depends on the look you're going for, whichever one's going to look best. The highlights are kind of playing around with the way the bump is set up, so it might need to go the other way. It's really just kind of preference, unless you're trying to be completely exact about it. So for the highlight, it's going to depend on the type of wood, whether it's finished or unfinished, for what you're going to be connecting it to. But what we can do is set a variable highlight, edit the function, and then connect the highlight output or output node to the desired numeric value. And basically, we need to use the conversion for the color to brightness. For finished woods, the darker areas of the surface tend to have a higher highlight. And then you can just use an opposite filter if you're going to have unfinished wood. So if you also want to change the overall color, you can go over to the Color tab and just kind of modify the overall color to make it darker or more towards a specific color, instead of having to go in and modify the color map. If it's getting too dark, you can lift up the color amount, maybe lighten it a little, and then go over to the Effects tab, and if you need to darken it, you can decrease the diffusion, unless it's getting too white. So that's the overall color change. Otherwise, you can go back into the function itself, and I'm going to change my diffusion back to 60, go back to the Color tab, right-click on that color, reset it, and because we have that HLS shift in there, we can modify the hue to shift towards a certain direction, and then if we want to increase saturation, we could just use those sliders pretty easily. Now another thing we can do if we want to increase the amount of rings being created is to use another filter before we reach the color map. So instead of just using the multiply, we can add a filter and change this to the absolute wave, or you can use a sine wave and just kind of adjust those values. It also creates a lot more variation in the surface. But those are just some neat little things you can do besides using multiply. Right now the bump, I think, is set a little too high for how many rings we have, which is why it kind of looks like crap. We really have to start using broadcast and anti-aliasing at this point. So I'm going to just delete that for now. We could also connect the reflection output to the same we did for the highlight to add a lot more to the surface. So right now we basically have a veneered wood. And if you're not familiar with how wood is cut, a veneer is when they shave the log in a circular direction from the outside to the core and create these large sheets, which is why this basically looks just like that. Because instead of having one continuous circular ring or one large ring descending inward, what we have is patches of the noise showing up throughout, so it does look more like a veneer. So if we want to create just long strips and lines to make it look more like wood that has been cut normally in solid wood, one of the easiest things we can do is remove the Z scale from the fractals. I am going to create another object, just creating a cylinder, and it's going to have a duplicate material created because of the way my settings are. File options, there is a setting to carry over that material. You can turn it on or off. Once we edit the material and make a modification with just the object selected, it will create a duplicate material. We'll just go ahead and call this wood 2 so that it is separate. But what we can do is go into the function and under any of the fractals or noises, just change the Z scale to 0. And that's going to work because the surface is up and down, and I do have my Z-axis up. So that does work quite well for creating those thin lines. If needed, you might want to add another fractal with an increased roughness in order to vary the surface a little bit more. But if we take a look at the top, what we're going to see is basically the same surface. But then once we hit anything that's going to be vertical or on the sides, it's going to get cut out. If we want to modify the rotation, because I have everything stretched out on the Z-axis, and if we wanted to use this on an object that isn't oriented, where we would have the shape stretching out upward, the easiest way to really modify that is to go to the Effects tab, click on Rotation, and then we can modify the rotation of the material this way. So this is going to rotate around, and in this case, what I would want to do is rotate it on the Y 90 degrees. So basically just kind of picture the rotation along that axis in order to see how it will be oriented. So this is going to be stretching a lot more, and since we don't have a flat surface, we are seeing the cutout. So that would be more likely to show up on the cube because it is a flat surface. And if you're going to be looking at it from the same direction, you can also rotate the Z-axis or the X and just kind of orient it to get what you're looking for. I think I am going to go and modify the X and remove the rotation on the Z. And you can see some nice variations too with the way the noises will be set up. So there's some cool stuff you can do there. So now if we do the X and the Z, we have another variation. And now we can see those lines kind of going in the other direction on this side. So you might just need to kind of play around with that to get it oriented for your object. And if you want to create different types of wood, you can use different fractals, changing them to different variations, kind of trying things out, different roughness values. There's also the ability to add a turbulence node that you can extract in origin, replace with a turbulence node, and use these just like fractals and create some pretty interesting results. So I hope you learned a few things from watching this training. And I think we're pretty much finished here. And I'll go ahead and save these scenes out. So if you're using version 8.4 or higher, you will be able to load them in.